Think back to the first time you played with a magnet. You bring two pieces close, and suddenly, without touching, they snap together, or they push apart, almost like they're refusing each other. No strings, no visible force, just empty space, and something happening inside it. At that moment, you probably asked a simple question: why? Why do magnets attract? It sounds like the kind of question that should have a clean, satisfying answer. After all, we've built entire technologies using magnetism, motors, generators, hard drives. Modern civilization depends on it. So surely we must understand it completely. But here's where things get uncomfortable. We don't. If you ask most people, they'll give you an explanation. Something about north and south poles. Opposites attract, like repels, like it sounds complete. It feels like an answer, but it isn't. It's a description. It tells you what happens, not why it happens. Imagine asking why the sky is blue, and someone replies, because it's blue. That's what most explanations of magnetism sound like. Once you really look at them, they rename the mystery. They don't solve it. Even physicists, the people who understand magnetism at the deepest level, will tell you the same thing in a different way. They can describe the behavior with incredible precision. They can predict exactly how magnets will interact in almost any situation. But when you keep asking why, you eventually reach a boundary, a point where the explanation stops. And that's strange, because we're used to thinking of science as something that explains everything, as something that can dig deeper and deeper until nothing is left unknown. But magnetism challenges that belief. It gives you an answer and then takes it away, because the closer you look, the more you realize that the simple question, why do magnets attract, is not as simple as it seems. It's one of those questions that feels easy on the surface, but opens into something much deeper, something that forces you to rethink what it even means to understand something. And that's where this story begins. At this point, your brain reaches for something familiar. You've heard this before. Magnets have two poles, north and south. Opposites attract, like poles repel. It's one of the first scientific rules you ever learned, and it feels complete, almost too complete, because it gives you a pattern. You bring two magnets together, and their behavior matches the rule perfectly. Opposite ends snap together, same ends push apart. It's consistent, predictable, reliable, and that's where the illusion begins. Because your brain mistakes prediction for understanding. Just because you can describe what will happen doesn't mean you know why it happens. Think about it carefully. When you say opposites attract, what are you actually explaining? You're labeling the behavior, not revealing the cause. You're observing a pattern and turning it into a rule, but the rule itself doesn't tell you anything about the mechanism behind it. Why should opposites attract? What is pulling them together? What exists in that empty space between the magnets that allows one to influence the other? The textbook answer doesn't go there. It stops early. It gives you just enough structure to make sense of the behavior, but not enough to understand the deeper reality. It replaces a question with a rule, and the rule feels satisfying enough that most people never question it further. But if you push even slightly beyond that surface, things start to feel incomplete, because the idea of poles is not a cause. It's a description of how magnets behave under certain conditions. It tells you how to predict the outcome, but not what is physically happening between the two objects. There's no visible connection, no contact, no medium you can point to and say, this is what's doing the work. And yet, the effect is undeniable. Two objects, separated by empty space, influencing each other with precision. That should feel strange, but the simplicity of the model hides that strangeness. It makes something deeply mysterious feel ordinary, and once you realize that, you begin to see the limitation of what you thought you knew, because the rule opposites attract is not the answer. It's the beginning of the question. Take two magnets and hold them a few centimeters apart. Don't let them touch. Just bring them close enough and wait. You feel it before you see it, a resistance, a pull, something pushing back against your hand, or drawing the magnets together. Like there's an invisible string between them, but there isn't. There's nothing there. No wire, no air movement, no visible connection of any kind. And yet, the effect is real. That's the moment where your intuition starts to break, because everything you've learned about the physical world tells you that for something to move, it has to be pushed, and for it to be pushed, something has to touch it. But here, nothing is touching anything. The magnets are interacting across empty space. Now pause and really think about that. What does it mean for one object to influence another without contact? It means something is happening in the space between them, not empty space, the way you usually imagine it, but a space where influence exists, even when nothing visible is present. When you move one magnet slightly, the other responds immediately, not because something traveled from one to the other like a particle or a substance, but because the effect is already there, filling the region around them. It's not delayed, it's not mechanical, it's direct. And that's what makes it so strange, because you're not watching an interaction happen step by step. You're watching a relationship that already exists, revealing itself as the magnets move closer or farther apart. The push and pull is not something created at the moment of contact. It's something that's always there. You're just moving through it. And that idea is difficult to accept, because it means space itself is not passive. It's not just an empty stage where things happen. It's part of the interaction. It carries the influence, even when you can't see it. So when two magnets attract or repel, you're not seeing objects reach out and touch each other. You're seeing the effect of something already present in the space between them. And once you notice that, the question changes. It's no longer, why do magnets pull? It becomes, what is it that exists between them? To make sense of that invisible push and pull, physics introduces a powerful idea. Not particles, not strings, not hidden objects, fields. Instead of asking what travels between two magnets, physics asks a different question. What exists around them? Every magnet is surrounded by a magnetic field. An invisible region of influence that extends outward into space. You can't see it directly, but you can see what it does. It tells other objects how to behave. It defines how space itself responds near the magnet. Now imagine placing another magnet into that field. It doesn't need to be touched. It doesn't need a signal sent to it. It simply enters a region where rules already exist, and those rules determine how it moves, whether it's pulled closer or pushed away. So the interaction is no longer mysterious in the same way. Nothing has to travel between the magnets. The field is already there. This idea solves a huge problem. It replaces the strange notion of action at a distance with something more structured. Instead of objects magically affecting each other across empty space, they interact through fields that fill that space. It gives you a way to describe what's happening, but only up to a point, because now a deeper question appears. What is a field? It sounds like an answer, but if you push it further, it becomes another layer of mystery. A field tells you how forces behave, how energy is distributed, how objects will respond, but it doesn't tell you why the field exists in the first place. It's like having a map without knowing who drew it. Physics can describe the field with incredible precision. It can calculate how strong it is, how it changes, how it interacts with electric fields. In fact, magnetism and electricity are not separate forces at all. They are two aspects of a single, unified electromagnetic field. That's a major breakthrough, but even that doesn't reach the bottom, because at the deepest level, the field is something you have to accept. It exists, it fills space, it governs interactions, but it is not explained in terms of something simpler. And that's where the word almost matters. The field explains how magnets work, but not why. There is something that can do the explaining at all. At this point, you've followed the question as far as it seems to go. Magnets don't touch, yet they interact. Fields fill the space between them, guiding how they move. Physics gives you equations, models, predictions, tools that work with incredible precision. And for most purposes, that's enough. You can build machines. You can generate electricity. You can design entire technologies around magnetism without ever needing to go deeper. But the original question is still there. Why? Why does a magnetic field exist at all? Why does it have the properties it does? Why should one magnet influence another across space, following rules that seem so consistent and yet so fundamentally unexplained? This is where science reaches a boundary, not a failure, but a limit, because science is incredibly powerful at describing patterns. It tells you how things behave, how they change, how they relate to each other. It builds models that predict outcomes with astonishing accuracy. But when you keep asking why, you eventually arrive at something that cannot be reduced further, something that simply is. Magnetism is one of those things. You can describe it, you can use it, you can connect it to deeper theories like electromagnetism and even quantum physics, but at the core, there's a point where explanation stops and acceptance begins. And that realization is uncomfortable because we're used to thinking that every question has an answer waiting at the end, that if we just go deeper, we'll uncover the final reason behind everything. But sometimes, the deeper you go, the more you discover that the universe does to explain itself in the way you expect. It reveals patterns, it reveals rules, but it doesn't always reveal reasons. And that doesn't make science weaker. It makes it more honest, because instead of pretending to know what it doesn't, it shows you exactly where understanding ends and mystery begins. So when you ask, why do magnets attract? You're not asking a simple question. You're touching the edge of what we can explain. And that edge is not empty. It's filled with something deeper than answers. It's filled with wonder.